mad scientists back in their game conducting our control trial test 2. And we just measured the mass of the egg, and the mass of the egg is 57.1 grams before the crash. And then now we're going to conduct the trial.
And as my partner lines the egg in the car up with the 31.5 or 18-inch line, the front of the wheels, and the metal platform with the 31.5-inch line, I will get ready with the calculator. Okay. Ready? 1, 2, 3. So as you can see, as the graph interpreted, the force in Newton was negative 5.871 newtons. So that's the force, and this is the graph that the calculator interpreted. The elapsed time for this test was 0.52 seconds. Before I show you velocity and acceleration, we will examine the egg.
And we can see the egg kind of crashed really badly. But we can see this because there was a sudden force.
A sudden shock, and the driver, as you can see in the graph, the line goes down and comes back up really fast.
And the before trial,
and in the before trial, there was great force, but it was spread out, thus not having as much cracks.
Now, back of the egg, there is no cracks at all. So it only received force in the front of the car. And now we're going to measure the mass of the egg.
And the mass of the egg after the crash is 56.8 grams. And as you can see, it decreased by 0.3 grams.
And we can see, like, as we predicted, the mass of the egg did decrease. So, and now my friend or partner is going to explain the acceleration and velocity.
So how we measured the velocity was the displacement over the elapsed time. The displacement being 18 inches from the wall to this white line, and dividing that by the elapsed time, which was 0.52 seconds. So that equaled to 34.6 centimeters per second. Then to find my acceleration, I divide the velocity, which was 34.6 centimeters per second, divided by 5.2 seconds. And I get 66.5 centimeters per second, and that was the acceleration. So this concludes test 2 of our control trial. And this is the Mad Scientist. Thank you very much.